Hello everyone, this is lecture 81 of Principles of Electric Circuits. We simplify the model of the air core transformer based on last lecture. We have two assumptions. First, we assume that the air core transformer is lossless, that is, R1 and R2 are equal to 0. Secondly, we assume that the coupling of the two coils is unity. These two assumptions may be correct for the real transformer. That is to say, we can get a very small resistance by using very thick conductor, and we arrange the coils properly and use a magnetic core with high permeability to obtain very high coupling factor. Under the assumptions of unity coupling and lossless, what's the simple expression of the relationship between the voltage and the current of both sides of the transformer? After ignoring the resistance, under the current reference directions of the voltage and the current, we can write the equations. We use KVL to the primary side and get we also use KVL to the secondary side and get solving the equations, we can write out because the coupling factor is 1, that is so the two items in the equation can be eliminated. Then we can get in lecture 77, we said that the self-inductance is proportional to the square of the number of turns, and the mutual inductance is proportional to the product of the number of turns of two coils. Thus, L1 over M equals N1 over N2. We define N1 over N2 as the turns ratio, denoted by M. Do you find? Under the assumptions of unity coupling and lossless of the air core transformer, we got a concise expression about the voltage of the primary side and the secondary side. That is to say, the primary voltage is equal to the secondary voltage times the turns ratio. Let's have a look at the expression about the current of the primary side and secondary side. By using the same equations, we can get similarly, because L1 is proportional to the square of N1, L2 is proportional to the square of N2, and M is proportional to N1 times N2. So for the turns ratio, it's equal to N1 over A2 or L1 over M, also M over L2, and the square root of L1 over L2. So for the first item of the equation, we can know for the second item of the equation, we can know substituted these two expressions in the equation above, it is a relationship of the port current for unity coupled transformer. We also write the relationship of the port voltage here. These two equations constitute all the relationship of the voltage and the current for the unity coupled transformer. Do you find, under the assumption of unity coupling and lossless, the transformer can achieve the function of ideal voltage transmission? That is, the ratio of the port voltage is the turns ratio of the coils, but the relationship between the two port currents is not simple. The primary currents can be divided into two parts. The first part is equivalent to the current in the impedance supplied by the primary voltage, and the second part is equivalent to the function of the current transformation. In the next lecture, we will further simplify such an equation. Well, that's the end of this lecture.